Hi everyone. Today we are going to discuss application of partial differentiation, that is Jacobian. Now in this topic we discuss about how to find the continuous and differentiable functions and its a partial differentiation. Now let me start from first point. When u and v are the functions of xy, then you have to take continuous its partial derivative as, that is a Jacobian of uv with respect to xy. So this is more applicable for, we have to find, suppose the product of two function is given and we have to solve them, so it can be solved by using also chain rule is there. So let me start first. What is the definition of Jacobian? Let's see. If u of xy and v of xy are continuous and differentiable functions of two variables x and y, such as x and y, then Jacobian of, that is the name of scientist here, so I am writing now in capital letters, so first letter is a capital, so Jacobian of u and v, that is it can be denoted by Jacobian of u comma v with respect to here the two variables here x and y, is denoted as that is Jacobian of uv, that is u comma v upon x comma y. Means what is that? That is Jacobian of uv with respect to xy, or this can be also denoted as, that is second notation, Jacobian of uv in the form of partial differentiation. So let me write here, that is a dabba uv, or we call that is a del uv upon del xy, or simply we have to denote it by capital J, and is defined as that is Jacobian of u comma v upon xy, means Jacobian uv with respect to xy. This is given as, it is a determinant of, that is a dabba u divided by dabba x into here dabba u divided by dabba y. In second row you have to write here dabba v divided by dabba x, and next dabba v divided by dabba y. Because of that, u and v are the functions of two variable, that's why we have to differentiate u with respect to x and y and differentiate v with respect to x and y. So you observe this is 2 by 2 determinant, right? In first row you have to write the partial differentiation of u with respect to x and y, and in second row partial differentiation of v with respect to x and y. Or there is another notation for denote this Jacobian. So it is a simply determinant of, that is ux uy, and here vx vy, where ux and uy, these are the partial derivative of u with respect to x and y, and vx and vy, this is also partial derivative with respect to x and y respectively. So similarly, if you have to given three functions, now let me discuss in next slide. Let's see. Similarly, if u comma v comma w are the three functions of x comma y and z, then Jacobian of u v w with respect to here x comma y comma z is simply in a notation, you know that you have to denote just it is capital J, or you have to denote now in this way, that is a j of. So how many functions is there? Three function, u, v and w, divided by, with respect to, I am writing here x, y and z, means u comma v comma w upon x, y, z, or simply you have to also write in the notation of partial differentiation, that is a dabba u v w upon dabba x comma y comma z, right? So this is nothing but this is also a determinant. But how many variables are there in a determinant? There are three variables. So the order of the determinant is 3 by 3. So let's see, order of determinant is 3 by 3, means what is that? In the first row you have to write all the derivatives of u with respect to x, that is a partial derivative of u with respect to x, with respect to y and with respect to z in the first row. In the second row you should have to write second variable, and it's a differentiation, that is a partial differentiation. So second variable is what? V. So dabba v upon dabba x, next dabba v upon dabba y, and next dabba v upon dabba z. Now remaining variable you have to write here its derivative, dabba w upon dabba x, dabba w upon dabba y and dabba w upon dabba z. We call this is a del also, right? Means del u v w with respect to del x y z. Also there is another notation, or I am writing here, or the notation is what? You have to just write in short form, that is in first row derivative of u, that is a ux, then uy, then uz, next here vx, vy, vz, and next one is here wx, wy and wz. Right, this is all about the definition of Jacobian. I hope so you have to understand this. Now after that we discuss the definition. After the definition we discuss here properties of Jacobian. Now let me start properties of Jacobian. Properties of Jacobian. So what are the property of Jacobian? Let's see. So there are three property we discuss here. So first property, if u and v are the functions of here simply two variables, so that is x and y, right? And the Jacobian is defined here, that is a dabba uv upon dabba here x comma y, and we have to also find if j is dabba uv upon dabba xy, then j dash can be written as this is dabba xy with respect to dabba u comma v, right? So you know this very well. If j is this, j dash is its reciprocal. If Jacobian is there, j dash is its reciprocal. Means, or I am writing here, then you have to just assume what is that j and j dash. Means j and j dash, that is equal to, this is dabba uv upon dabba x comma y into j dash is dabba xy upon dabba uv. Okay, I hope so you have to understand this uv and this uv, means these are the cancel here and you will getting the result j dash is equal to what is that? 1. So that is the first property we discuss here, j into j dash, that is equal to 1. I hope so you have to understand this. Now let me start property number second, right? So property number second is what? That is all about here. This property is related to chain rule, that is chain rule of Jacobian. So what is the chain rule? Let's see easier. Suppose u and v be the two functions and these are the different function of x and y. So let me write here, if u equals to f1 of here x comma y. So what is that? U equal to some function f1 of xy, comma v is also equal to, there is another function we say f2 of xy, and there is one more I am writing one more function in the form of x and y. So x is nothing but now x is equal to, that is some another function, x is equal to, that is we call the another function phi 1 of r and theta, phi 1 of r and theta, and the y is equal to, that is here phi 2 of r and theta. So let's see here, y is another function, that is a phi 2 of r and theta. Okay, so let's see from here, if u and v are the different functions of xy, and again x and y are the functions of r and theta, then 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 how it will be calculated the Jacobian of uv with respect to here xy, with respect to xy. This can be done by using this formula. Let's see what I am writing here, that is a dabba uv upon here dabba. First, you see here, u is a function of u and v are the functions of xy, right? And x and y are the functions of r theta. So by definition of composite function, you know very well, by definition of composite function, just you have to write down here, u is a function of. So I'm also telling, or I wanted to also show here by using the graphical method. Suppose u and v are the functions of here x and y. So let's see, u and v are the functions of x and y, and these x and y are the functions of here r and theta. So r comma here theta. So by definition of composite function, u is a function of r and theta. So that function is called as here composite function. Composite function, right? So in this way you have to just calculate here, then dabba of uv upon dabba of r theta. So how it will be calculated? So just let's see, in this way we have to calculate it. First of all, uv is a function of what is that xy, means I am writing dabba uv upon dabba xy into xy is a function of here r and theta. So that's why we have to just differentiate xy with respect to r and theta. So let's see, that is into dabba of here x comma y divided by dabba of r and theta, right? I hope so you have to understand this chain rule. So this is called as, this is called chain rule, right? This is called chain rule of Jacobian, of Jacobian. I hope so you have to understand this point. So what is the first property? J into j dash equal to 1. And what is the second property? That is all about here the chain rule. It's similar like chain rule of differentiation. That is chain rule in here partial differentiation, means chain rule in here Jacobian. So the chain rule of Jacobian is true for functions of 3 and more variables. So there is a note I am writing here. This chain rule is true for Jacobian of, means I am writing it is a functions of 3 and more variables. Means the Jacobian chain rule, it is applicable for 3 and more variables. So by using this rule we have to just find what is the derivative of the composite function, or what is the Jacobian of composite function. So these are the property number second. Now let me discuss next property, that is property number third. Let's see. So here property number third. So property number third is, what is that here? Let's see. The function u comma v of two independent variable, the function u comma v are, or these are the functions of two or more independent variable, means I'm writing just is in this way, if u and v of two independent variable x comma y are functionally dependent if that is a dabba uv upon dabba xy that is equal to 0. Means there is a property, and this is very important. So let's see here. The functions of uv means the function uv of two independent variable x and y are functionally dependent if and only if it's a Jacobian equal to 0. Means in some example you wanted to show here, so the function is a dependent or independent. So by using this result you have to show it is a dependent or not. Right, this is property number 3rd. So in this discussion we are totally discuss here. So I am writing some remark, or that is a summary type here. Summary type remarks are here. So number 1, what is the property? That is a j into j dash that is equal to 1. Number 2nd, what is property? If you have to find dabba uv upon dabba r theta by using composite function. So first of all dabba uv with respect to dabba xy, and then dabba xy with respect to dabba r comma theta, means with respect to r and theta. So if when these we have to write, you have to getting here u and v are the functions of here x comma y, and x comma y are the functions of here r and theta, then we have to use the chain rule. So this is chain rule for Jacobian. This is chain rule for Jacobian. Next and third property, the function uv are said to be functionally dependent. Means if u and v of two independent variable of xy are functionally dependent for u comma v are two independent variables x comma y are functionally dependent if there is a result. What is that result? uv dabba uv with respect to dabba xy that is equal to here 0. Means just you have to satisfy this Jacobian that is equal to 0, then we say the u and v are functionally dependent. I hope so you have to understand the definition of Jacobian and what are the properties of Jacobian, right? Thank you.